questions, and then we'll do them. But of course, feel free to make a start.
Okay.
This is good. Okay. So how are we doing here? Okay, so this looks good. So typically with these ones, we can kind of separate them out. So we can do 7x to the 4 divided by x, which gives us the 7x cubed. The minus 2x cubed divided by x gives us minus 2x squared. And the plus 6x divided by x gives us 6. And the same kind of thing is applied to these other ones. And then here you have the minus 6 divided by 2x, where the 6 and the 2 divide, giving you 3. Cool. And then on the next slide, these are ones that are just achieved with factorizing. Nice. Yeah, you got it. Cool. Yeah, and the top one even recognized straight away x plus 3x plus 4 cancels, and yeah, good stuff. Cool. So now the thing that we're getting into is ones like slide 3, because this one's not as easy, because unless you know already, up to GCSE, we haven't actually learned anything for being able to factorize a cubic. So dividing by x minus 3 is a little bit... Ugh. So this is where the long division comes into play. And we set it up like this. So we have x minus 3 out here, just like bus stop method, or the initial setup anyway. And we have here x cubed plus 2x squared minus 17x plus 6. So when we do long division, we normally start with the highest place value. So let's say the thousands, if it's the highest one, then you go to the hundreds, then you go to the tens, and you go to the units, taking, of course, any remainders that you have. It's the same kind of thing here. So we take the leading term of the x minus 3, which is x, and the leading term of the x cubed plus 2x squared minus 17x plus 6, which is x cubed. And by leading term, we just mean the term with the highest power.
Okay.
So x into x cubed, or in other words, x multiplied by what gives you x cubed?
X squared.
So the x squared goes up here. And then to be able to work out the remainder, we do x squared multiplied by this x minus 3. That's going to give us x cubed minus 3x.
Okay.
And then the thing that you would do with your division is you would take this away to work out what the remainder is. So we do x cubed take away x cubed, which is nothing. 2x squared, 2x squared take away, sorry, this should have been an x squared. 2x squared minus 3x squared, 2x squared minus 3x squared is plus 5x squared, because you're taking away the negative 3. And then you've got the minus 17x take away nothing is minus 17x. And you've got the plus 6x take away nothing is still plus 6. And then we go again. Now we've got the remainder. We now ask ourselves, okay, x into 5x squared, or x times what gives you 5x squared?
5x.
So we now put 5x at the top, and then we go again. So we've got 5x multiplied by x, which is 5x squared, and then 5x multiplied by minus 3, which is minus 15x. And then again, we subtract to work out what the remainder is. So 5x squared take away 5x squared is nothing. Minus 17x take away minus 15x is minus 2x. And then you've got the plus 6 take away nothing, which is still plus 6. And then we go again. That's our remainder. So x into minus 2x. So x times what gives you minus 2x?
Minus 2.
Indeed. So we put minus 2 there, and then we do the same thing. Minus 2 multiplied by this x minus 3, which gives you minus 2x. And then that gives you plus 6, because it's minus 2 times minus 3. Then again, we subtract. So minus 2x take away minus 2x is nothing. And 6 take away 6 is, again, nothing. So overall, our remainder is 0. So that division works. Given that this is the remainder of 0, what does that tell us about x minus 3 in relation to our x cubed plus 2x squared minus 17x plus 6?
That if you were to factorize x cubed plus 2x squared minus 17x plus 6, x minus 3 would be one of the would be in one of the brackets.
Nice, yeah, because it's a factor. That's it. That's exactly it. So when you factorize, we are basically writing something as a product of its constituent factors. So we may as well extend this to this question then. So you could now factorize this as this x cubed plus 2x squared minus 17x. By the way, this is not part of the question. This is just me saying what we can do with what we've done, which is now going to be, this can be written as x minus 3 multiplied by the thing that we've got as our answer. So x squared plus 5x minus 2. As far as I'm concerned, the x squared plus 5x minus 2 cannot be factorized. Yeah, because there aren't two numbers that multiply to give minus 2, but add to give 5. At least not whole numbers, so yeah.
Okay.
How are you feeling with this? Do you want to go for another example together, or do you think you can try one?
I think we could go through another example together.
Another example, I think that's good. Cool. All right, I have x plus 5, and that's going into 6x cubed plus 28x squared minus 7x plus 15. Okay. Then we have, so first thing, x into 6x cubed, or x times what gives you 6x cubed?
6x squared.
Indeed. So the 6x squared goes above here. Then at this stage, we take the 6x squared, multiply it by the x plus 5. So 6x squared times x gives you 6x cubed. 6x squared times the plus 5 gives you plus 30x squared. And then we take that away to work out the remainder. So 6x cubed, sorry, take away 6x cubed is 0. 28x squared take away 30x squared is minus 2x squared. And then minus 7x take away nothing is minus 7x. 15 take away nothing is plus 15. Okay, and then we go again. So we have x into minus 2x squared.
Which
Or
is minus 2x.
Indeed, minus 2x. Minus 2x multiplied by x is minus 2x squared. Minus 2x multiplied by plus 5 is going to be minus 10x. And then at this stage, we subtract to work out our remainder. So we've got minus 2x squared, take away minus 2x squared, which is nothing, 0. minus 7x take away minus 10x is going to be plus 3x. And then you've got the 15 take away nothing, which is 15, positive 15.
Mhm.
And then we go again, x into plus 3x.
Would be 3.
Yep,
Plus 3.
plus 3. So 3 times x is 3x. 3 times plus 5 is plus 15.
Mhm.
And then we subtract, so that's 0 plus 0.
Okay.
So if you like, our factorization for this becomes x plus 5. So this cubic term becomes x plus 5 multiplied by 6x squared minus 2x plus 3.
Okay.
And as far as I'm aware, I do not think this 6x squared minus 2x plus 3 factorizes.
Okay.
In fact, using the b squared minus 4ac, I can see this wouldn't factorize. Minus 2 squared is 4. 4 take away 4 times 6 times 3 is definitely less than 0. So yeah, no solutions. So yeah,
Okay.
cool. Um, Again, these examples are quite lengthy that I've given you, but when I ask you to do some of the other ones, it will be fine. Do you want to go through another one together?
I think I can try one.
You sure?
Yeah.
Okay.
Wait, I just need help with one part.
Yep.
I'll put it onto the board.
Sure.
Uh,
Wow, that
okay.
is long. Mm-hmm.
So what I've done is x goes into minus 3x to the power of 4. It goes into, wait, up here I'd put minus 3x to the power of 3.
Yep.
And then I'd multiply minus 3x to the power of 3 by x, which gives me minus 3x to the power of 4.
Mm-hmm.
Then minus 3x to the power of 3 times minus 2 gives me plus 6x to the power of 3.
Yep.
Now here, if I minus these, then I'll
Mm-hmm.
get, never mind, never mind.
Okay.
I just see where I went wrong.
It's all good.
Okay.
So it happens. It happens to me a lot. I think one
Yeah.
of the reasons why I make fewer mistakes is because I know that I have to explain it to someone else. So I can't like rush. I've noticed that even now when I try questions on my own, I make so many mistakes. Oh man.
Okay.
Ooh.
Yeah, so these would just cancel out.
Mm-hmm.
Okay. No, no, I can do it. It's fine.
Okay, cool. Yep, 2x cubed. Mm-hmm. Then x into. Okay, so is that with the x into minus the x into 2x cubed?
Mm-hmm.
So that's just going to be um a positive 2x squared at the bottom then, right? As opposed to a minus. Unless that minus is applying to taking, okay.
Yeah. Oh, sorry. Yeah, I should have. Wait, no. Oh, okay.
So this
Yeah,
bit
that minus would be. Yeah. Okay. Never mind.
that you're taking it all away.
Mm-hmm.
Cool.
So that left me with. That left me with 0. Yeah.
Entirely?
No, not entirely, but from the 2x cubed minus 8x squared, that part left me with 0.
Okay.
So what I wrote was
Oh, hang on. Yes.
okay. and I had a remainder of 16.
Remainder of
16.
Oh, I realized. Yeah, there's a mistake actually. So, um, okay, when you did x into 2x cubed, and that gave you 2x squared.
Mhm.
So from this line,
Mhm.
so when you multiplied that by x minus 2, that gives you 2x cubed. But then
Instead
this
of
bit,
minus 4.
yeah, it should be minus 4. Yeah, I was wondering, like, how did so much of it disappear so quickly? Yeah,
uh,
but it's all good. We can just change it here.
okay. So
I wrote that out. Mhm.
so then that leaves me with 8 minus 8x minus.
Yep, minus 4x squared.
And then
So we can write out our top bit as well.
so x goes into that minus 4x times.
Mm-hmm. Mm-hmm. Yes, plus 8x. And that's going to change this. Yep.
So 13x minus 8x. That leaves me with 5x
Mm-hmm.
minus 10.
Mm-hmm.
Because of the 5 times. So
Yes, all of this just cancels down to
mhm.
0. Nice. So yeah, again, this,
Yeah, that was a really silly mistake.
yeah, no, it happens. Again, it happens. Because I didn't even notice the mistake.
Hmm.
So until later, I'm just thought, oh, hang on. Yeah. So okay, in staring at that, how is that?
That was okay. That was okay. I think I understand the method. It's just that one like silly mistake that caught me.
Mm. Right, we'll go through another one. I'll go through this one. Just because there is a small trap. Well, sometimes these are small traps which people often forget because of not laying out um their work. Though I think you probably would do it because I did see instances of you do it in the previous example. So this one we're going x minus 2 into x cubed minus 3x minus 2.
Mhm.
So first thing you'll see is there's no x squared term.
Okay.
So a good way to sort this out, just to make it look presentable, is rewrite this as x cubed plus 0x squared minus 3x minus 2.
Okay.
Now, some might think that 0x squared is redundant, but actually it helps us to remember that we still have to subtract any x squared terms that we get, because we could still get x squared terms.
Mhm.
So x into x cubed is x squared. X squared multiplied by x is x cubed. X squared times minus 2x. Sorry, x squared times minus 2 is minus 2x squared. And then we subtract. Now, most people would have missed this part and would have been like, oh, there's nothing to subtract the 2x squared from. And then all sorts of silliness and craziness and imaginative behavior starts to occur. So here we have 0 take away minus 2x squared, which is positive 2x squared. And of course, x cubed take away x cubed is 0. Then we've got the minus 3x and we've got the minus 2. Then x into plus 2, x squared is plus 2x. 2x times x is 2x squared minus 4x. And then again, we subtract. And then that gives us 0. Minus 3 take away minus 4 is 1. So that's plus 1x. And that's minus 2 because the minus 2 drops down. and then x into plus 1x, well, that's just 1. And then we have 1 times x, which is x, and then 1 times minus 2 is minus 2, and then that's nice. It simplifies to 0.
Okay.
But if we notice, so that means x cubed minus 3x minus 2 factorizes to x minus 2 multiplied by x squared plus 2x plus 1. I'm just going to allow you to stare at this answer for long enough, and you might notice something.
So x cubed plus 2x squared. Okay. 2x squared plus 1x
So
minus 2x squared.
it's more so the answer that I want you to stare at,
Okay.
or the factorization that I've done, should I say? Because this bit, they're not asking us to do it, but this is just me pointing out some things. Whilst you do, I'm just going to make my arrows look a bit nicer.
Is it that you can factorize the x squared plus 2x plus 1?
Nice. I knew that if I gave you enough time to stare at it, you'd realize, yes. So what does that factorize to?
X plus 1, x plus 1.
Yeah. So we can actually fully factorize cubics in this way because of this. And of course, this can be further simplified to x minus 2 multiplied by x plus 1 squared. So again, they didn't ask us to do this, but that's just me making some observations here.
Mm-hmm.
Cool. So is that okay for you?
Mm-hmm.
Cool. I'll let you try one of these where there's that. Actually, I think this one should be. Cool. Okay. Let's go for this one. You might find that there's a few things. There are a few things that happen, but it's all good. Nice. You put the 0x term in, which is good. Mm-hmm. Wait, you see here how you got 12x minus 36? When you do x into 12x,
It's 12.
yeah, as opposed
Not
to
4. Okay.
So I'm just going to get rid of that 4. Oh, okay. You do it.
So that's 12x minus 96.
Mm-hmm.
Let me take that away. You have to go 0.
Yeah, because when you do 12 times x, you get
12x.
yeah.
Okay.
Cool.
And that means our final answer would be x squared plus 4x plus 12.
Yeah, for when you divide it, indeed. And if they
Did
were
you
to
want me
ask you,
to factorize it?
I mean, you can, yeah. So the factorization just on this side, it's not something they ask for. They're not asked them. It's not something they've asked for in this question, but it is something that they could ask you for. So, yeah. And I do not think, yeah, this one doesn't factorize, so it's all good.
Okay.
Okay. Now, not everything is nice. And let me explain what I mean by that. Not everything is nice. You may or may not be able to see what will happen, but we'll see. And just by looking at this question, are there any hints that might suggest this is different? On the surface, it looks like the same kind of question. So slide 8, by the way. I mean, this is quite a an ambitious question that I'm asking, but is there anything that might suggest that this one is a bit different?
So if that was to start solving it,
I mean, yeah, of course, you could just start to go through the process.
what I can tell without starting
Mm-hmm.
is that if I have when I have x squared up here,
Mm-hmm.
it can't the x squared times plus 5. Wait, no, that's not it. That's not it.
I'll give you a clue. It is something to do with that plus 5. And maybe if you look at the ending of the cubic term, the plus 2.
So before,
Mm-hmm.
if I had a term and I multiplied it by the plus 5,
Mm-hmm.
I could use that to cancel out the last term of uh,
Mm-hmm.
what's inside the bus stop
Yeah.
thing. Yeah.
Yep.
But in this case, there's going to be a remainder.
Indeed. Yes. That's it. That's exactly it. It's going to be a remainder. I mean, if you think about factorizing this,
Mm-hmm.
this is going to be x plus 5. The other thing is going to be some quadratic,
Mm-hmm.
x squared plus something something plus something x plus something. But 5 times, there isn't a whole number that multiplies by 5 to give you 2. So yeah, that suggests there's going to be a remainder.
Mm-hmm.
So we'll work through. So x into x cubed goes in x squared times. X squared times x gives you x cubed. Um, then we have x squared also times 5x, which, sorry, times 5 gives us 5x squared. Then we subtract 4x squared, take away 5x squared is minus 1x squared. And that's minus 3x, and then that's plus 2. Then we go again. So x into minus 1x squared is minus 1x or minus x. Minus x times x is minus x squared. Minus x plus times minus x times 5 is minus 5x. Subtracting, we get 0. Minus 3 minus 5 is plus 2, so that's plus 2x. And we drop down the plus 2. Then we have x into plus 2x, which is plus 2. 2 times x is 2x. 2 times 5 is 10. So that gives us minus 8. So in this fact, this actually tells us that the remainder equals minus 8. Writing that would be x cubed plus 4x squared minus 3x plus 2, all divided by x plus 5, in actual fact equals the answer bit that we get, so that's like our whole number, x squared minus x plus 2, and we always add the remainder bit on top of the thing we were dividing by.
Okay.
Just like when we have, for example, 2 into 5, let's just say, we'd go 2 into 5, that goes in 2 times, and our remainder is 1. So therefore, 5 divided by 2 gives you 2 and 1 over the thing we're dividing by.
Okay.
So 2.5. In the same way, we've done the same thing here. The remainder minus 8 goes over the thing we're dividing by. Does that make sense?
Mm-hmm.
Cool. So, okay. Could you do this one? Okay. Yep.
Okay.
Nice. All looking good. Okay, and then I guess one question here. Given that x minus 1 is a factor of 5x cubed minus 9x squared plus 2x plus a, find the value of a. So, well, we could actually do, I mean, there is another way to do this, but I'm purposely not going to show you this other method because it's a good way to extend your long division work.
Mm-hmm.
But I want to see what you can make of this long division method. Okay, so you've gone for it. Minus 4x. Be very, very careful. So you know you put minus 4x squared. Minus 4x times minus 1 gives you plus 4x.
Okay.
So again, be very careful. You're
Or
starting,
a plus 2.
yeah, and it's a minus 2
A minus 2 because
because
of the
you're
minus here.
subtracting.
Okay.
So this is what you're left with, and you can't really do much more because there are no x's in it. But
Right.
what do you know about that a minus 2? Because that's your remainder.
That it's a minus 2 over x minus 1.
Well, there's a bit more that we can say. They've told us that x minus 1 is a factor.
Okay.
So if we've been told it's a factor, what does that mean?
That means that you can divide 5x cubed minus 9x squared plus 2x plus a. You can divide that by x minus 1 and still have a whole, like, you won't have any remainder.
Exactly. So that a minus 2, which looks like it's a remainder, what is the value of that
A.
if there's no remainder?
A.
Well,
No, wait. Not too sure.
okay. It just means that this, which is our supposed remainder, must be equal to 0 because by definition of a factor, there's a 0 remainder and there's no remainder.
Okay.
Because you know how with all the other ones where they were factors, if you just look back to the previous examples,
Okay, it ended with 0 every
yeah,
time.
ended with 0. Slide 7 ended with 0. Slide 6 ended with 0. Slide 5 ended with 0. Slide 4 ended with 0. Slide 3 ended with 0. It's suggesting that they were factors.
Okay.
So this one as well, well, it ends with a minus 2, but a, we don't know what it is, but we know that it must end with 0.
Okay. So then that means a has to be plus 2.
Indeed.
Okay.
You want to try another one like that?
Sure.
Nice. Well, remember for putting the 0x. I was almost about to say something. I thought, you know what, let me not say anything. I think you'll notice. And you did. Um. Okay, cool. Let's see what you've done.
Wait.
Can I suggest one thing with how you lay out the what you've got?
Sure.
So, because everything is in terms of x squared,
Mhm.
at this stage is you've got the minus bx squared and you're taking away the 18. So I'd probably go like this. Minus b minus 18 x squared, like that.
Okay.
It just helps you identify, okay, all of that is my coefficient of x squared.
Got it.
Mm-hmm.
Okay, so
Oh. And that last bit, so you multiplied b minus 18
Mm-hmm.
by x.
Mm-hmm.
So you'd have b minus 18 bracket x.
Wait, could you say that again? B minus.
So that last, so you see how you got plus b minus 18 at the top up here. And you then,
Okay.
so the next step would be to multiply that by x.
Right.
So it'd be b minus 18, oh, sorry, minus b minus 18 multiplied by just x on its own, rather than having the 3 as well. Does that make sense?
No.
So you know how every time you get a new thing, a new term,
Mm-hmm.
you multiply it by the divisor, which is your
Yep.
x plus 3, and then you get your answer down here.
Mm-hmm.
So that's what we're doing here as well.
Okay.
So when you do minus b minus 18, oh, never mind. Sorry. No. You had it right. You had it right. Never mind.
Okay.
That was my mistake. Ah, yep. And then, yeah,
Okay.
yeah, you had it right. I don't know what I was. Ignore me. Yep, yeah, just ignore me. I feel like I made you lose your trail of thought. My bad.
Wait. So would that be correct?
I'm just checking. Did I even? Okay, so take away, take away. Ah, okay. So if that plus 18, okay, there shouldn't have been anything extra here, I believe. As in the 18 just drops down there. And yeah, this would be correct.
Okay.
Does that make sense?
Yeah, that makes sense. Okay.
Mm-hmm. Counting at 3, yep, minus 9. Mhm. Yep. That's your so-called remainder.
Because I know x plus 3 is a factor.
Mm-hmm.
That means 18 minus 9 minus b minus 18
Mm-hmm.
is equal to 0.
Yep.
Then I can just solve this for b,
Yep.
which gives me
Mm-hmm. Yep. Yep. Nice. B is equal to 20. Minus 20.
okay.
Yep. And then, yeah, at this stage, you could even go on to say what the quotient would be. We know it's going to be 6x squared. And then we know b is minus 20. So minus 20 is 20.
Mm-hmm.
Minus 18 is 2, so plus 2x, and then we've got the minus b minus 18, so minus 20, which is 20, minus 18, which is 2, minus 3 times 2 is minus 6. And yeah, it gives you that.
Okay.
And yeah, nice. I would say you've got a very, very good grasp there of long division.
Okay. That's good.
So yeah, if you want a challenge, one problem,
Okay.
that's this. It's one where you've got two unknowns